Coming up, understanding insect flight.
These tiny flyers, they only have a very limited amount of neurons. However, they are able to solve extremely challenging flight control tasks like the upside-down landing on the ceiling.
A stunning snapshot of a solar eclipse.
Total solar eclipse is a moving shadow. And so if you can fly with the shadow of the moon blocking out the sun, then you can extend the length of totality, as they call it.
Finding every species of fish.
I've spent a lot of my life on the interface between science and art.
Funding for this program is made possible by the Corporation for Public Broadcasting, Sue and Edgar Wachenheim III, and contributions to this station.
Hi, I'm Bill Hallman in for Mike Zeman. Thanks for watching SciTech Now. From airplanes to drones, humans have been engineering aircraft for more than 100 years. But all of those inventions start to look pretty simple when you start to study the flight of insects. Take a look. When the Wright brothers studied flight, they studied the seagull. Elegant and efficient, they were easy to observe and easy to emulate. But there was another type of flyer on that desolate North Carolina beach. It was more dynamic than the seagull, and it broke all of the rules the Wrights worked so hard to uncover. The fly. Based on what we know about flight, this guy should drop like a rock. A group of Penn State scientists, led by Bo Cheng, are trying to figure out why it doesn't.
This is a relatively simple question to ask, but an extremely difficult one to answer since it requires us to study various aspects of insect flight that includes their flight dynamics, their aerodynamics, the structure and functions of their biological sensors.
To most people, flies are pests. But to an engineer, these insects can perform tasks that have no equal in the natural world.
These tiny flyers, they only have a very limited amount of neurons. However, they are able to solve extremely challenging flight control tasks like the upside-down landing on the ceiling within a split of a second.
This doesn't seem like a big deal, but keep watching. Now imagine you're in an airplane, and the only way to land is upside down at a fixed location. No existing aircraft is capable of performing this type of maneuver, and if it did, it would take an exceptional pilot to pull it off. Flies do it hundreds of times a day. Cheng's team is interested in their brains and their aerodynamics.
In fact, they use highly unsteady and rotational flow to generate lift, and that's something perceived as pretty bad for conventional engineered flight.
The basics of conventional flight go something like this. As a plane speeds up, air splits above and below the wing. The air at the top moves faster over the curved surface, creating low pressure. The pressure difference between the top and bottom of the wing creates lift. Flies create lift another way.
When the wings are moving, they generate their own aerodynamic lift, but then the LEV, the leading edge vortex, which is on top of that, introduces an extra suction force which pulls the wing further up and helps the insects to hover or just to fly and not fall down, basically.
Think of the leading edge vortex as a small tornado, a rapid swirl of air riding at the top edge of the wing. Like the airplane, the fast-moving air creates low pressure, and that creates lift. To study this, Cheng's team has created unique devices that help them contain the flies and record them at 5,000 frames per second.
So what we do is we attach a fly to this end of the rod, and we sort of just put it back in. And what will happen is the fly will start flapping its wings, and it'll sort of fly in a circle.
Flight mill uses electromagnets to levitate the rod. This keeps the fly on a predictable path. Upside-down landings are recorded using this, a plexiglass cube surrounded by lights and high-speed cameras.
Essentially, we can track different points on the wing and then get the three-dimensional coordinates for these points on the wing or on the body. And then we can essentially reconstruct the wing motion as well as the tiny deformation of the wing. And then we will have a full understanding of the kinematics of the flight.
The team is also partnering with the University of Virginia to understand the fluid dynamics. They want to know how wing movement can affect the stability of that leading edge vortex we just talked about. The team is also looking to the future. Humans have already harnessed the power of flight, but can we take it to the next step and copy the complex movements and reaction time of bugs? Right now, there are robotic flyers that can mimic the basic mechanics of an insect, but according to Cheng, a mechanical device capable of something like this is still decades away. For now, all we can do is watch and learn.
Dave Mosher is a science reporter who's written for Scientific American, Popular Mechanics, National Geographic News, and Discovery.com. Throughout his career, he's watched humans and robots launch into space toward a cutting-edge nuclear reactor and flown over the North Pole to catch a total solar eclipse. He joins me now to share what it's like to experience that up close and personal. So, first of all, why fly over the North Pole to see an eclipse?
So actually flying over the North Pole isn't part of the goal, but it's on the way, so you might as well just finish the journey and go over and say, hey, we did it. The reason you would do that is because a total solar eclipse is a moving shadow. And so if you can fly with the shadow of the moon, being blocked out, the moon blocking out the sun, then you can extend the length of totality, as they call it. So these crazy eclipse chasers will book these charter flights. They do it every eclipse, and they spend tens of thousands of dollars sometimes, between travel and booking the charter flight and meals and entertainment and all that, just to fly under the totality of the eclipse.
So this is something, this is a thing. This is a particular kind of tour that people, so you also have to, this flight has to go in the path of where the shadow's going. It's not necessarily a, New York to Tokyo type of flight.
Right, so these are really wild, trajectories you get on because it's all determined by the orbits of Earth and the moon and the sun. Like it's all sort of celestially predetermined when these things are gonna happen. So they booked these crazy pathways, and the one I happened to be on in 2008 was going straight for the North Pole from Dusseldorf, Germany. So we flew over Svalbard and some other places on a very strange flight path. But in that flight path, we got to hang out in the shadow of the moon for much longer than you would be able to from the ground. And in fact, very few, if any people would have seen that eclipse had they not been in an airplane, because it was just cutting across the Arctic Ocean.
And this is, the shadow extends over the entire kind of visible spectrum or whatever you are from that plane. So you're essentially traveling in kind of a weird non-darkness, but non-sun.
Yeah, the people that were part of this trip were trying to explain this to me because they've been doing this for decades. They are hooked. Once you see a total solar eclipse, you need to see another one because you only get a few minutes, and that few minutes is just indescribable. You're in everything gets cold, everything gets dark, the birds stop chirping, weird things happen. It just seems very odd, and no wonder throughout history people have seen these as terrible omens or things like that, because it's just uncanny to really be here. The funny part is total solar eclipses happen all the time. They happen once every year or two. It just depends where you're at on the Earth and the alignment of the moon happens to be.
So While you're in that plane, everything around you, I mean, is it basically like you're crossing the international time zone? I mean, it's just sort of that weird twilight at the edge of the horizon. Do you see where the shadow doesn't exist anymore?
Yeah, so when I was looking out this airplane window, it was almost like an immediate sunset, if that's how I would describe it. Like someone just like turned off the light, like what just happened? And you look down and you can see this sort of like fuzzy edge of the shadow because there's totality where it's totally dark, where we were at. And then there's like this peripheral sort of like sunset-like zone because the sun is bending around the moon and diffracting and making these sort of like reddish, ruddy colors. So you're sort of in this like circular sunset, and it's very strange. And you look up at the sun and you can see the corona, the outer fringes of the sun, sort of spewing out of the from around the moon. And that's one of the few opportunities we get to ever see the corona because the sun is so bright, it's hard to block it out.
So while they're in the aircraft, are there people who are trying to take photographs of this? I mean, it's not perfectly steady, but how do they do it? I mean, because it's so rare to see these coronas.
Yeah, so there's people design apps just to figure out the exposure settings for your DSLR camera and stuff. And the guy, one of the guys in the flight's like, oh yeah, here, you have this camera, we'll use these settings, and like it'll come out just right. And it did. Like they're very obsessive. And this is like what I think the fun part of the eclipse is you have to know so much, you have to learn so much about astronomy and physics and just the mechanics of everything to understand what you have to do in that particular moment and why it is happening the way it's happening. But yeah, they're lining the whole side of the plane where just people, you know, placarded with their cameras and their faces. There were, of course, discount seats on the other side where you couldn't see the eclipse.
All right, Dave Mosher, thanks so much for joining us.
My pleasure. And I'll just note that on August 21st, 2017, there will be a total solar eclipse strafing across the entire United States. It's going to cover 14 states. Hotels are already booked solid, I'm sure, but most of the United States will see the sun, the moon pass in front of the sun during that time.
For how many hours, you think?
It's going to be minutes.
Oh,
just minutes. A few minutes.
Okay. All right. We'll look forward to it.
Yeah, my name is Dmitry Dregulev, and I'm the founder of Just Reach Out. It's a SaaS product that helps entrepreneurs and small companies, small businesses reach out to relevant journalists and bloggers and influencers, but mainly press, and get publicity and exposure from it. I've done PR work for about 10 years, and I've noticed that small businesses, primarily entrepreneurs, professionals, really struggle to find the relevant journalists that they should pitch, and they don't know how to do that. And PR firms cost a lot of money. And if you're just a scrappy team with 10 people or 15 people, you can't pay $10,000, $20,000 a month. And so I worked on a project that got acquired by Google, and after that I said, enough is enough. I gotta build something that helps entrepreneurs and small companies pitch press effectively, that doesn't clutter the inboxes of all these journalists out there. We have about 4,000 companies and businesses that use us at this point. It's been live for about a year, and we have companies like Symantec, Airbnb, and Chess.com, and Nickelodeon, and some of these HubSpot, some of these bigger brands. As well. Mostly it's smaller companies, professionals. Literally, if you're a Bitcoin expert, so you know a lot about Bitcoin, you put that term in, and the tool goes out there and finds who are the people who write about Bitcoin a lot, but also mention it in social, like Facebook and Twitter and all these different platforms. These journalists, influencers, if they're talking about Bitcoin, chances are they're interested in it. And if you have something interesting or innovative to say about it, you guys should chat. And so it fronts up those people for you, and then it gives you email templates that are best used for each and every journalist out there, tailored to them. So there's about 9 pitch templates modified for them. You modify those templates and you hit send, and the email actually leaves our servers, not yours. It'll be emailed on your behalf, and you can track and see if they opened your email, how many times, if they replied, everything from our platform. And we also show you popular Quora questions or Reddit discussions or any kind of discussions out there that are happening around your expertise, your area of expertise. You can put in as many keywords as you want, and you can put in competitors' names, you can put in all sorts of different things to see what comes up, and it's always changing, so the algorithm always finds new results for you all the time. The idea is to make it more relevant so that you're not just pitching to anybody who's covering tech, you're pitching to somebody who's covering Bitcoin and this Bitcoin app world, for example, and you're in the Bitcoin app world, and so it matches the two. Basically, justreachout.io, that's the site, you can come check it out.
There are 121 state parks in Pennsylvania. They're all worth checking out, but only a handful have the habitat necessary to produce some very interesting plants. Here's a look at the hidden carnivores of the Commonwealth. Welcome to Black Moshannon State Park. 3,400 acres of protected land surrounded by another 43,000 acres of state forest. It's about as private as public land gets. When you're here, don't count on cell phone service or Wi-Fi. The tweets and snaps are organic, the science is all natural, and the bog is really worth sharing.
A bog is a wetland area, so you're going to have soils that are going to help hold the water in, low nutrient counts, and you're going to have plants that are only specifically found in the bog, like the carnivorous plants, the leatherleaf, and the sphagnum moss.
Don't worry, we're going to talk about the carnivores, but the moss is the main ingredient in this habitat.
The sphagnum moss is found all throughout our bog area, and as the rain comes down, as water is filtering into it, it actually can clean out any pollution that may be in the water, so it helps give us good water quality.
The water is clean, but it's not very nutritious. The moss absorbs the minerals and replaces them with acids, not a great environment for plants, unless those plants have another source of nutrition. Black Moshannon is home to 3 types of carnivorous plants. The pitcher plant is the easiest to find.
That is our pitcher plant colony. There's a few of those scattered throughout our bog area. They grow in very large quantities. As the bugs fly into it and go down inside the pitchers, it's actually producing an enzyme which is going to break down the insect so it's able to get some of its food that way.
The pitcher plant is absorbing nutrients like nitrogen and phosphorus. So does the sundew, but it has a different strategy.
The sundew is one of our carnivorous plants, and that is going to look like the sun with little rays coming off of it. And the little tiny dewdrops on it are actually a type of glue that the plant produces, so the insects get stuck to that. And they actually will kind of close around it just a little tiny bit, and that is going to break down the insects and get its food.
When it comes to the bladderwort, all of the action is happening under the water.
Bladderwort is found throughout our lake area. It actually looks like seaweed, and it looks like it has little tiny black seeds on it. Those seeds are actually the bladders, and they have a little tiny trap door on it. So as an insect such as mosquito larvae would swim by it, it triggers that door, and it opens up, and it sucks in the water in the insect and then closes itself around it.
The carnivores love the bog, but don't get the wrong impression. This is not a desolate wasteland where all bugs meet their doom. It's an intricate and diverse ecosystem.
We have over 80 different kinds of dragonflies and damselflies here. You can see larger animals such as bear and bobcat like to be in those areas. And it's also providing nice clean water for the fish that like to live in our lake area behind us.
It's also one of the only places in Pennsylvania where you can pick wild cranberries. Okay, let's do this. It's pretty sour. It's good. So if you need a day to simplify, why not unplug and relax in one of the most complex environments in central Pennsylvania?
Carbon black is a material found in tires that makes the rubber stronger and gives tires their distinctive black color. But a new food waste technology may have you seeing more colorful tires in the future. Professor Katrina Cornish of The Ohio State University has been researching the use of tomato peels and eggshells as a replacement for carbon black. Professor Cornish joins me now via Google Hangout. So first of all, for most of us who don't pay attention to tires until they run flat, what's a tire made of?
Well, a tire is made of two different sorts of rubber, synthetic rubber and natural rubber, and then all sorts of other things like steel and nylon and various other pieces, as well as the metal in your wheel rims. But the tire itself is black because of the reinforcing filler that creates a lot of the strengths required. Now, tires don't have the same ingredients, all of them. So an airplane tire, for example, is 100% natural rubber, whereas your passenger car tire has some synthetic and some natural mixed together, or in different parts of the tire.
And so where do the tomato peels and the eggshells come in?
Well, the reinforcing fillers that is carbon black, we're using these as replacements for some of the carbon black, because we found that microfillers produced from tomato peels and from eggshells are actually, like carbon black, reinforcing fillers. They add strength. They don't just dilute the rubber as an extender. They actually make it stronger in the same way that carbon black does.
And you picked those two partly because of the kind of commercial nature of the excess tomato peels and excess eggshells that apparently exist, not just from my garbage can.
That's correct. These are produced in very large quantity at food processing plants. So the amount produced in the States is extremely large. So, for example, we have over 430,000 metric tons of tomato peels produced every year in the US, and we have over nearly 600,000 tons of eggshells, and more than half of that is at food processing plants where you could go in and collect it very easily. So I'm not suggesting we go get your breakfast eggshells, so we'll leave those be for the moment anyway.
Right. So, and you have in your lab the material that's made out of them. Would that end up influencing how a tire looks? Would it look a little bit more reddish brown?
Yes, with the tomato peels you could, but carbon black is very black, so you'll be looking at, slightly reddish brown. If you still have carbon black in there, that would be the issue. However, we have also made these materials with nano eggshells, so we can do a complete replacement there. But we're not really suggesting that, because this would be a very expensive tire. But you could make that one colored. And then we're also looking at these as partial or full replacements of the silica filler that is used in certain specialty tires as an alternative to carbon black. And those materials can be colored too. We actually made some bright yellow ones last week.
How do the tires with your fillers that include tomato peels and eggshells, the composites, how do they compare with the tire that I might buy at a store today?
Well, at the moment, I do want to be clear, no tires have actually been made. We're making the compounds and testing test specimens, but they actually compare very well. And then very comparable, because we're using carbon black as our control. So we're not saying one bio-based filler or waste-derived filler is better than another one. We're saying, how does this stack up against the industry standard? One thing that we do get are some interesting shifts in the combinations of properties. So normally a reinforcing filler, the more you put in, the stronger it gets, but the stiffer the tire gets, the less elastic it gets in that material, until you reach a point of failure where there's just too much filler. But we're breaking that paradigm a little bit. So we might be able to say, okay, if you want the same strength and you want the same hardness, but you'd like to keep some elasticity that you wouldn't normally be able to get, we can keep some of that in for you. So those three major properties are a little bit disconnected with our fillers, which hasn't been seen before.
So how would that help a driver?
For example, in a snow tire, where you want to have particularly good grip, something like that, you might be able to have an advantage. Or if you've got a tire that's going over very rough terrain, you need it very strong. But if it's like the pink Jeeps in Sedona or something, you might want to be able to go over your off-road tires where you can really go up the mountainside and need more grip, but you also need the strength. So you can have all the strength you need, but still have more squishiness, if you like, so it can hold onto the terrain better.
What happens to most tires? Do they end up in landfills? And would the filling in your tires decrease that impact in any way?
Well, That's hard to say. A lot of tires end up in landfills or in giant tire piles. There's more and more work going on trying to recycle them, so that they get the metal taken out of them and they end up in asphalt or children's playgrounds. So there's more and more work in that area. Our materials wouldn't affect those sorts of destinies. In terms of degradability of the tire, of course, our tomato peel filler would be somewhat degradable compared with what's in there. The eggshells wouldn't, but they are inside the tire. So unless you break up the tire in some way so that they're accessible to the air and to water, they wouldn't be degradable any more than your regular fillers, because they just wouldn't be accessible in that way.
All right, Katrina Cornish from Ohio State University. Thanks so much for joining us.
Okay, thank you very much. It's been my pleasure.
In a tiny island laboratory, one marine biologist is on a mission to scan every known species of fish in the world. He wants to turn them into 3D models that could change the way we study fish in the future. Environmental reporting partner EarthFix has the story.
I've spent a lot of my life on the interface between science and art. Understanding shape in an aesthetic way, presenting these skeletons in a visually arresting way, often leads to new insights. Why do I like that angle? Why do I like that color map? I like that color map because it's bringing out some detail that I later realized is really important. If it took between, say, 4 and 10 hours to scan a fish with exquisite detail, you'd spend more than a career scanning 33,000 of them. The big innovation here was the idea to do lots of species at the same time. What we do is we package as many as 20 species of fishes all at once into a sort of fish burrito, and then put them in the micro CT scanner and get data from all of them all at once. I've scanned 3 times as many fish in the last few months as I'd scanned in the previous 15 years. This is an amount of information that's just awe-inspiring, and it really does represent a huge increase in our body of knowledge about one of the most diverse and important group of vertebrates on the planet.
You can watch full episodes of SciTech Now on demand and online at wpsu.org/digital. I'm Bill Hallman, filling in for Mike Zeman. Thanks for watching.
Funding for this program is made possible by the Corporation for Public Broadcasting, Sue and Edgar Wachenheim III, and contributions to this station.